Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and we are continuing our discussion of the sine rule, the sine rule, hence the part 2. We just have one more example to do it, and we had to continue with the great Jerry Lee Lewis and the classic Great Balls of Fire. All right, let's get to it, shall we? Our last example showed you how it's possible that there are two solutions for an angle of a triangle, okay? And you always have to check. So here's another take on that. Let's see, triangle KLM, and you can just draw any old triangle and then label it and be able to figure this out, yes? So KLM, okay? And given that angle LKM measures 52 degrees, LKM, so that's this angle right here, 52 degrees. LM from here to here is 158, and KM is 128, okay? And we have to find the measure of angle L. So I'm looking for this angle right here. So right away, I'm going to put sine L on top, capital L, over the length of the side opposite it, 128. And that is equal to, and I know this angle, 52 degrees for K, and I know the length of the side opposite of it. So I can put sine of 52 degrees on top, divided by 158. Okay, then using cross multiplication here, boom, boom. You don't have to draw that in. I'm just drawing it in to illustrate what's happening. So I have 158 times the sine of L is equal to 128 times the sine of 52 degrees. I'm going to divide both sides by 158 by 158. And that cancels out. So then I get sine L equals 128 times the sine of 52 degrees divided by 150. And I'm looking for angle L, so I have to use arc sine. So L is equal to the arc sine, which, by the way, is I forgot the C, is the same as sine -1, right? Of all of this junk, 128 multiplied by the sine of 52 degrees over 150. Okay, and we'll see what that equals. I'm just going to draw a little arrow here, which is equal to, and we'll round to the nearest tenth here. Let's go to Desmos. Hold on one second. 128, 52 degrees, 150. Just so I don't have to go back and forth. So I'm going to go to Desmos. I need arc sine. Okay, and I'm going to have a fraction. So I'm going to put this first part in parentheses, and that's 128 times the sine of 52 degrees. Okay, so I'm going to divide that by 150. Okay, and I'm in radians, so I need to change to degrees. Wham, bam. Awesome. And I get 42.3 degrees rounded to the nearest tenth. So that is equal to 42.3 degrees. Okay, so I have found the measure of angle L is equal to 42.3 degrees. Now remember from the last video, there's another possibility. It is possible that L could also be equal to 180 minus 42.3 degrees. So let's see what that is equal to. I guess we could do it in our head, but let's go back here, 180. Just to be sure, 180 minus 42.3. and that is 137.7. So that's right here, 137.7 degrees. And you might say, oh, okay, that's my other answer. But you always have to check. We already know, we are for sure know that angle K is 52 degrees because we're told that right here, correct? So if I take 137.7 and I add 52 to that, what do I get? I get 0.7, 5 and 3 is 8. I get 189.7 degrees. Okay? Well, that is greater than 180 degrees, and that is impossible in a triangle, so this is not possible. So you always have to check that when you check your other angle. So whenever you find the measure of the angle in a triangle using the law of sines or the sine law, you have to subtract your answer from 180 and then check and see if it's possible by adding the given angle and seeing if it's greater than 180 degrees. If it's greater than 180 degrees, then it's not possible. But if it's less than 180 degrees, then it is possible, and you would have two different possibilities for the angle that you find. All right, hope that makes sense. That is the only example for this video. We will go out with the great Jerry Lee Lewis. Let's see how he's doing with his fire. He's still playing the piano. Hope you enjoyed it. And I am out.